I'm going to discuss. So the first question, let fx is equal to 3 minus 5x here. Now, you have to find the domain. So in square rooting, what you know, inside should be greater than or is equal to 0. Right? So you get 3 minus 5x greater than or equal 0. And then you get minus 5x greater than or equal minus 3. Right? And you are dividing by minus. So that would be 5x. Then you change the sign into less than equal. If you're multiplying or dividing, you change the sign, right? So x would be 3 divided by 5, right? So that's the way to go. So 3 minus 5x should be greater than or equal 0. So minus 5x should be greater than or equal to minus 3. Then x should be less than or equal 3 divided by 5. So your domain would be minus infinity to 3 divided by 5. Right. Why you are having this bracket? It's because of this equal thing. Okay, so that's it. So the next one, find the derivative of fx. Okay, so you're asking to find ddx of 3 minus 5x square rooting. So this is a 2-mark question. You know, I can do it like in just a second, but when I'm doing a paper, I don't do it. So what I do, so I introduce this half power times d 3 minus 5x divided by dx. So you can use using chain rule. Okay, so when you do that, you get 1 divided by 2 3 minus 5x here square rooting, and that is coming from this part times, then you get here minus 5, that is coming from this part in differentiation, right? So the answer would be minus 5 divided by 2 3 minus 5x square rooting. Okay, and then find the exact value of that. Very easy. So this is nothing but your f dash x now. So f dash 1 divided by 5. So you put 1 divided by 5 here. So 2, 3 minus, if you put 1 divided by 5, right? So it's going to be 1 here. So 2 square root 2. Okay, so if you want, you can say minus 5 square root 2 divided by 4. Okay. So that's that question. Now, in second question, you can see 6 marks here, right? Find fx, consider fx is equal to sine 3x. Evaluate fx. So you can see this capital Fx. So typically, now with your experience, you know, integration of fx dx is written as capital Fx, right, plus k. Similarly, you know, ddx of simple fx, you write f prime x, right? So that's why, if you remember earlier, a to b fx dx is written f of b minus f of a. In other words, this is nothing but fx with a and b boundaries. Okay, so now you need to find this. So fx is equal to integration sine 3x dx. Okay, so you know we can do this in one shot, right? So this is cos 3x minus 1 divided by 3, right, plus k. Given that f0 is equal to 0, why it is given that? To find k. To find k, right? That's why f0 when is equal to 0 is given to you. So that means boundary condition would be at x is equal to 0, fx is equal to 0, or that's what they have written, f0 is equal to 0. So you have to understand the language. So 0 here, when applying that here, it's 0 minus 1 divided by 3. Cos is 0 here plus k. So you know that cos 0 is equal to 1. So k is equal to 1 divided by 3. So you finalize your answer. Fx is equal to minus 1 divided by 3 cos 3x plus 1 divided by 3. Now, hence, I don't like this term, hence solve the equation fx is equal to half. So you have this domain given. So minus 1 divided by 3. So cos 3x plus 1 divided by 3 is equal to half, right? So when you simplify this, what do you get? Minus 1 divided by 3 cos 3x is equal to, so now when you put this guy into the other side, so it's going to be 6, it's going to be minus 1 divided by 6, right? Right? Minus or plus? Plus, right? Yeah, plus 1 divided by 6. So now you can see cos 3x is equal to minus half. You have the domain 0 to pi, right? So 0 to pi. Okay, before that, if you have the inside, complicated inside, you do a substitution. So you get cos k is equal to half minus, where k is, now you put 0 here, so it's going to be 0, and you put pi here again, so it's going to be 3 pi, right? So now what you do, how many marks here? 3 marks. Yes, reasonable. So now cos k would be like this, right? Would be like this, right? So 2 pi comes here, then 3 pi comes here. Okay, so now you need sorry, it's minus half, guys, minus half. So minus half is here, right? How many solutions you are expecting? This much of solutions. Why? Because 3 pi is your boundary, right? So you are going to take this part. So 3 solutions you are expecting. Now how to get the first solution? K1, K2, K3. Okay, so how to get K1, K2, K3? How to get K1, K2, K3? So it would be right. So how to get K1 first, right? How to get K1, right? So this is very easy. You remember, if you consider plus half here, this value you obtain from the table. So this is cos 60, which is pi divided by 3, is half, right? So the meaning would be this gap is pi divided by 3, because it's 0 here. This coordinate is pi divided by 3, so the gap would be pi divided by 3 minus 0, which is pi divided by 3. So that's why I'm saying, when the coordinate is pi divided by 3 and the coordinate here is 0, this gap is pi divided by 3. You can see the symmetry. Now here, this gap is pi divided by 3. So that means from here to here, this gap also pi divided by 3. Okay, what I'm saying, this gap also pi divided by 3. Same as here, right? You can see starting from here. Okay, so this point here is pi. Okay, so now what I can say, K1 is nothing but pi minus pi divided by 3. Okay, so it's going to be 2 pi divided by 3. So what about K2? So K2 is nothing but pi plus pi divided by 3. Right? So it's going to be 4 pi divided by 3. What about K3? K3 would be, again, here's 3 pi, right? It's 3 pi minus pi divided by 3. So it's going to be 8 pi divided by 3. So once you have all K values, so K is equal to 3x. So what you can say, 3x is equal to k values. So the k values would be 2 pi divided by 3, 4 pi divided by 3, 8 pi divided by 3. So you can find x now dividing the whole thing by 3. So it's going to be 2 pi divided by 9, 4 pi divided by 9, and 8 pi divided by 9. Easy. So question number 3. Consider the function with the rule this. Find the inverse. Okay. Find the rule of inverse for the inverse of f. So from here, you know, y is equal to x minus 2 divided by x plus 2, right? So you know this structure is a very popular structure. If you see this one, you can write x plus 2, right, minus 4 divided by x plus 2. This is a popular structure. So once you have that, you can write 1 minus 4 divided by x plus 2 if you want, right? So that is 1. So now you need to find the inverse function. What you do, you swap the x and y's, right? So x is equal to 1 minus 4 divided by y plus 2. So once you have that, so it's just algebra, right? So it's going to be x minus 1 is equal to 4 minus divided by y plus 2. So here you get y plus 2 cross multiply minus 4 divided by x minus 1. So y is equal to 4 divided by 1 minus x minus 2. So that is the inverse function. So inverse of x would be that minus 2, right? So when you do that, so you have to be very careful. This is 3 marks, right? When you are defining a function, you have to define the domain properly. Otherwise, you lose 1 mark. So you have to say x is what? X is all real other than 1. Okay, so you have to do that properly. Okay, find the domain and the range of the function here. Okay, so the domain we have already found, right? So now range. So this is pretty easy. Why? Because you can see here you can see it's a 1 divided by x, right? So how it works now? So if you draw this one, you can say minus 2 is your y translation here. X translation would be 1, right? So when x is equal to 1, you have asymptote, right? Here. Why? Because when you put 1 here, you can see 4 divided by 0 infinity, right? So this is minus. The next thing to notice is this minus. So once you see that, if you don't have minus, right? If you don't have minus, how this looks like, this should look like this way. Right? Now you have a minus. So if you have a minus, it should look like this, right? Okay. So we still don't know your x and y intercepts. We don't need, actually, they're not asking anything, right? So the domain would be, you can see domain R except 1. Y would be what? Now again, y would be R except minus 2. Right? Because when y is equal to minus 2, you have asymptote here. You can see asymptotes here. So you are going to skip that point. And when you are considering y, x, you are skipping this, right? So that's it. Okay, here. Now show that f inverse x can be written in the form of this. Oh, I think we did that already. We did that already. Yeah. So f inverse x is equal to 1 divided by 1 minus x minus 2, right? So we did that already. So we will rearrange it, minus 2 plus, see, 1 minus 6. Look, we did that already in the first place. Okay, so that's how we do. Okay, so now you in this case, you can say a is equal to minus 2, b is equal to 1. That's it. Hence, again, I don't like this. Hence, find integration f inverse x. Okay, so integration 0 to half f inverse is minus 2 plus 1 divided by 1 minus x, okay, dx. Then you can split this. You split it, minus 2 dx plus, or maybe you can put minus. You can be smart here, right? You can be a little smart here. And then you put minus and you write 1 minus x as x minus 1 dx. Those things you have to do, when you are doing it, right? So you don't have time to decide those things in the exam. So that's why we had to throw the experience. So integration of x dx would be x. It's going to be 0 to half minus this would be log, right? E base x minus 1, which is from 0 to half. So when you do that, so if you put half here, it's going to be minus 1 minus, in the log case, you have log. If you put half here, log half, right? Minus, if you put 0 here, sorry. Okay, so if you put half here, it's going to be log minus half, right? Minus, if you put 0 here, you get log minus 1, right? So now this is, you understand log minus half and log minus 1 is not existing, but still you can see it's a division. So you can write minus 1 minus log half divide by minus half divide by minus 1, like this, right? So that would be minus 1 minus log half actually, right? So this is the answer. Now you can be little smart here. Now when you absorb this one inside, you will see it would be minus 1. You can bring 1 or you can bring plus and then log 2 e base. Okay, all I base, right? So that would be the answer. So extensively you are using log properties. So if you know, minus log x can be written as log 1 divided by x. Similarly, minus log 1 divided by x can be written as log x. Those are grade 9, 10 log properties. Okay, hope you understand. Now, when it comes to here, the function fx is defined by this. Yes, 100%, 0 to 3. Fx is a fourth order polynomial. Find the stationary point. Stationary point means f dash x is equal to 0. So it's pretty easy. First of all, you find f dash x here. So f dash x is 1 divided by 4 times 4x3 minus 3x squared plus 2x, right? And you can do a little bit of simplification. Minus 3x squared plus 2x, and that should be is equal to 0, right? Because f dash x is equal to 0 for stationary point, for stationary points. Then how to do this one? So now you can see this is a cubic. This is a cubic. But if you have a cubic, typically what you do, you use factor theorem or rational root theorem, those kind of factorization methods. But here you observe x here. So you can take x out from this. So once you take x out, so it's going to be x squared minus 3x plus 2 is equal to 0. So now this is in your hand, right? So this is going to be x minus 1, x minus 2 is equal to 0. Now using null factor law, right? This is going to be 0, this is going to be 0, this is going to be 0. So x is equal to 0, 1, and 2. Easy. 3 marks. Nailed. Okay. Sketch fx on the axis below. So here, yeah, so you need to graph it. So to graph, yes, of course, you have to find the y coordinates as well, right? So when x is equal to 0, what is y? 0, right? Yeah. Am I right? Yeah. If x is equal to 0, y 0. Then when x is equal to 1, when x is equal to 1, what is y? When x is equal to 1, yeah, that would be 1 divided by 4, right? When x is equal to 2, what that would be? When x is equal to 2. When x is equal to 2, it's going to be 8, 4, minus 3, 16, 4. How much is that? When x is equal to 2 here, this is going to be 16, right? So it's going to be 8, right? This is going to be 4, right? So it's going to be 4 minus 4. Is a 0? Yeah, is 0. Okay. Now you have the next thing would be your boundaries, right? 0. Yeah, 0 is covered from here. Correct. Good. Now x is equal to 3, but 3 is not a stationary point, right? So we have to find the coordinate. When x is equal to 3, what would be the y value? So you put 3 here. So it's going to be 27 into 3, 81, right? So this is going to be 27. This is going to be 9. So 27 minus 9 would be 18, right? So it's going to be 81 divided by 4 minus 18. So it's going to be 81 minus, it's going to be 3676 divided by 4. So it's going to be 5 divided by 4. Am I right? Uh, 9, 27, 27.
9.
Say it again.
I got 9 before.
Yeah, 9 divided by 4?
Yeah.
Let's see. X into 3, 27. 27 plus 18, right? 18 into 4 is how much? 18 into 2, 36. 36, 72, yeah? Sorry, this is 72. So it's going to be 9 divided by 4. It's going to be, yeah, 2.25, right? Yeah, 2.25. So that means when x is equal to 3, y is equal to 2.25. So you can see, you have to feel this pain in the exam. Okay, so you know you have everything here, right? So when x is equal to 0, it is 0 here. When x is equal to 3, it's going to be 2.25 somewhere here, right? 3, 2.25. And then 0, 0 is here. So now you have to see the stationary points. 1 and 2, right? So when it is 1, it would be 1 divided by 4. When it is 1, it will be 1 divided by 4. 1 divided by 4 is somewhere here, right? 1 divided by 4 is somewhere here. It should be here, right? So now the way it is given here, right? So the continuation should happen, right? So it should go through like this, and then should hit here. Now you will see here, slope is 0, 100%. Why that? Because that's a stationary point. Here, slope 0, right? It's a stationary point. That's why. So here we got slope 0, but we don't know how it is continuing, whether it is going this way, whether it's a thing like this, we don't know, right? So we sort of leave it because we don't need to worry about that because they're not going to ask anything about that point. Okay, so this is how it is. Okay, so now find the area bounded by the graph. Okay, now see how the question is. Find the area bounded by the graph y is equal to fx between 0 and 2. So that means they're asking you to find this area. Okay, that area. So you have the boundary given, right? So this function is, what is that function? If I remember, that function is 1 divided by 4 x to the power 4 minus x3 plus x2, right? So that's the function, I think. So you need to find area, very easy. That would be 0 to 2, 1 divided by 4, x to the power 4 minus x3 plus x squared dx. Okay, so once you do that, you should get x3 here. Minus, what I do here, I have integrate, right? So 1 divided by 4, x5 divided by 5 minus x3 x4 divided by 4 plus x3 divided by 3, and you are applying 0 and 2 here. Okay, so once you do that, what is the answer you get? Can you tell me?
I'll go 4 and 15.
4 over
15.
15. Okay, so now this is the area, right? So you have to put square units. this is a must thing to put. Okay, remember. Okay, so solve the following. So if you have that, it's 4,000. You cross multiply 5 times 2 plus 7 3x. Then you can divide by 5. So if you divide by 5, it's going to be 800. So 2 plus 7 3x. So then it's going to be 798 is equal to 7 3x. Right. So now your goal is to find. Now your goal is to write this in terms of 7 to the power something. P. Okay. 7 to the power what will give you 798? 7 to the power what will give you 798? Okay. So it seems we don't have a proper thing, right? So it seems we don't have a proper thing. So we are lucky if we can write it in that way. So it seems you can't have a p-value, a whole number, so that you can make 798, right? How do you make sure that? Because 7 times 7 times 7 times 7, right? So look at the last digits. So this is going to be 49. 49 times 7. I mean, last digit would be 3, right? Then that 3 multiplied by 7, then 1, right? If you go for another one, then again 7, right? See, last digit. You have to be smart there. So you are not going to get 8 anyways, right? So you don't have to do the whole multiplications, right? So you have to be smart there to catch it from the last digit. So it seems not. So 7 3x is equal to 798. So if that happens, so the base is 7. So you introduce log 7 3x. So you introduce log to the right hand side, 798. So then if you have that, property would be you can take log 3x out. So it's going to be log 7 is equal to log 798. So that would be, this would be 1. So x would be 1 divided by 3. Log 798, right? And that would be the answer. So when you have this question, now you need to solve for x, right? You need to solve for x, right? So this is a very common question here. So you write 4 in terms of 2 and x out, plus 2x minus 1 is equal to 0. So 2 here, and then you swap the things, 2x and 2, plus 2x minus 1 is equal to 0. So let k is equal to 2x. So then you get 2k squared plus k minus 1 is equal to 0, right? So this shouldn't be bad. So k is equal to minus b minus 1 plus or minus b squared minus 4 ac 8 square root divided by 2a, it's going to be 4. So k should be minus plus or minus 3 divided by 4. So you get 2k values. One is when you get the minus value, it's going to be minus 4 divided by 4 is going to be minus 1. When you take the plus value, it's going to be 2 divided by 4 is going to be half. So now 2x is equal to minus 1, right? And the other one is 2x is equal to, okay, so 2x is equal to half, right? So once you have that, what do you do? Then 2x minus 1. So you can't solve this one, right? 2x minus 1. How do you make a x value so that you can get a minus value? So you have no solution here. You have no solution here, right? So you have no solution here. So, but here you can have a solution, right? So 2x is equal to 2 minus 1, right? So x is equal to minus 1. Okay, 6 probability, we'll skip it for now. Okay, question number 7. The tangent to the curve, right? You can see it's a parabola, right? At point x is equal to a, where this has gradient of minus 9, find the value of a. Okay. So now you can sketch this a little bit. So suppose this function is like this, 3 divided by x minus 2. At x is equal to a, right? So suppose this is fx, right? So that's why I told you, remember, if when x is equal to a, this is a, your y value would be f of a. You remember I taught you in our general training. So at that point, there is a tangent. There is a tangent. The tangent to the curve at point A, where A is greater than 0, has a gradient. So this has a gradient M, which is -9, right? So it's very easy. So the tangent is your f dash x at x is equal to A, right? So those are very basic things. That's your slope. So first of all, you will find your slope here, which is 3 1 divided by x, right? So it's going to be x -1, right? So -1 divided by x squared, right? So -2, a constant, when you get the derivative of a constant, is 0. So this is the answer for that, right? So slope, this is your slope. So slope at A, which is -3 divided by A squared, and that is equal to -9, which is given. So from here you get here 1 is equal to 3 A squared, right? A is equal to plus or minus 1 divided by square root 3. Right? And then read the question carefully, where A is a positive number. If A is a positive number, right? So we accept A is equal to positive 1 divided by square root 3. So if you want to rationalize it, you can. If you want to rationalize it, you can say this is going to be this. That's it.